This exercise provides a real-life example of combining datasets. Here we have a bunch of files, which are basically a web server logs. Those file logs are very important. These trace data are generated by many application servers, digital devices on a periodic basis. And this serves a good ground for many data-intensive operations, including data mining and auditing. In this example, we're basically looking at one web server log, and this web server log contains information about hits to the server or requests that clients are sending to the server. It's possible to use this data to mine, for instance, for some customer behavior, looking at click streams, looking at different aspects of people interacting with this web server. And again, there is like a public data set and some papers that have used this public data sets before in marketing. Let's take a look at the structure of this data. In this data, I took the log. The log itself is splitted across multiple files. And this is common in many kind of logs because the application, the server, generates these logs in a periodic basis, probably per hour, per day, per week. If you take a look at one of these files, you can see that it's a text file. So each entry in the file is basically a request. And this request comes from a certain IP address at a certain timestamp, and there is the resource, the request itself that the request is requesting, plus other information such as the protocol, the result, the response, the client, and so on and so forth. Now, if you want to know exactly what this file contains, you can take a look at the source documentation of the dataset. In this exercise, we're interested in the IP address as well as the timestamp. Now, if we want to do any analysis, we need to assemble this data because we have 10 such files, right? We have server log 00 to server log 09. So in this exercise, we're going to concatenate these logs in order to get a cohesive data set that we can use for any analysis. Well, there are two parts to this exercise. First, let's focus on one file. And what I have done here, I read the file, and because it's a text file, I read it as a CSV file. It's not really a CSV file because each line is formatted in a certain way that doesn't conform with a CSV format. So what I did, I used a separator of a new line, meaning I'm reading each line as a separate entry in the data frame. Let's load the packages here. And you can see that each line is now one row in the data frame. So what I want to do now, well, that's one line, right? We can take a look at one line and see what's inside it. It contains multiple fields, and again, if you take a look at this link, it will take you to the Nginx documentation. The Nginx is the web server that generated this log, and it will, talk about what's detailed in the log, specifically. Once again, we are interested in the IP address, and we are interested in the timestamp for the sake of this exercise. So this request is coming from this IP address on this, date stamp, time date stamp. So question 1, let's extract the IP address and timestamp into two separate columns and format the data as a data frame that has two columns here. There are multiple ways to deal with this string, the text. I'm going to use regular expressions. It's also possible to split across the dash because you can see that the different fields are split across the dashes. So it's probably possible to do some splitting and some post hoc filtering to extract the IP address and then the timestamp. I'm going to do a kind of a more specific approach, and I'm going to use regular expression just to practice regular expressions. And also regular expressions will be very precise when we deal with this string like that, so we're not kind of putting ourselves as the mercy of how this is formatted. So first, I'm going to put this in a variable called text. My kind of strategy here is to try to solve this for one string, one text, and then apply it on the data frame um, um, as a whole, right? So this strategy simplifies the thought process to solve the problem. First, solve it for one variable, a single value, and then isolate this in a function and then apply the function on the series or the data frame. So I'm going to import the package regular expression, and then I'm going to format a regular expression for the IP address. What's the IP address? The IP address is basically the internet address of the server or the client, and it basically, at least in the IP4 address, contains a series of 4 numbers. Each number ranges from 0 to 255, and those numbers are separated by dots. So that's the IP address here. Now, because this number ranges from 0 to 255, you can see that each part of this IP address can be either 1 digit, 2 digits, or 3 digits. So that's what I'm going to do here. I'm going to say, well, that's a raw string because I'm going to use escape characters. But first, we're going to start with 1 digit, and this digit can be 1 or 3, repeated 1 or 3 times. I'm actually going to be very specific here. I'm going to specify this starts with the beginning in the string. Look for 1 digit repeated from 1 to 3 times, and then a dot. Now notice that the dot is a special character for in regular expressions, so I'm going to escape the dot. Next, I'm going to do another digit 1 to 3 times, another dot, another digit repeated 1 to 3 times, another dot, and then another digit repeated 1 to 3 times. Okay, so I'm going to compile this now. re.compile this regular expression here. Let's try it. Let's do xp1. I'm going to find all text, and you can see it managed to extract this part of the IP address in the text. Of course, find all is going to try to extract all instances, and we only care about the first one. I'm not sure if there will be more, but we only care about the first one, so we take the first one, and that's what we get. We get the IP address. Okay, so now let's take a look at the second part that we need to parse, which is the timestamp. Now, the timestamp is much more complicated than an IP address. It's formatted as day, month, and year, and then there is like hour, minute, and seconds, and we probably have a time zone information. I'm not sure about this plus, so there are a bunch of things here. So there are two approaches here. Either we try to write a regular expression specifically for this, or we can take a shortcut. And in this shortcut, I'm going to rely on the fact that this date timestamp is being put within 2 brackets here. 2 square brackets. So I'm going to write my second expression here. And let's see how we want to express this one. Well, we need the 2 brackets here. Now, don't forget that the square brackets have special meaning in regular expression lingo, so we want to escape them. A square bracket indicate a group of characters, and that's not what we want here. I'm going also to put this dash here, so I'm interested in a dash space square bracket, and then another square bracket. Now, what's inside the square bracket is the timestamp that we took a shortcut to avoid representing here in a regular expression. So I'm going simply to say, well, it's any character repeated. So again, this regular expression may work in such, confined context. It's not the best way because it's kind of really relying on how the server is formatting that for us. So here we have 2 strategies here, either to be very specific and try really to express the pattern in all of its nuances, or to kind of be more pragmatic and just take a shortcut and rely on how this data is formatted in the text you have. Okay, so let's try exp2. exp2.findAll text 0 is going to give us this. Now I'm not interested in all of this, I'm only interested in what's inside it, right? Okay, so we are interested in what's inside this. So we can take a substring from the fourth character to the end, to the last one. So we can say, okay, 4 to -1, and that's going to give us the timestamp, actually 3 to -1, this timestamp, post hoc processing. Or just avoid the post hoc processing and let's do it within the regular expression. Within the regular expression, I'm going to say, well, that's the pattern, but once you find the pattern, I'm not interested in all of the pattern. I'm only interested in this part. And I'm going to make this part a capture group. I'm going only to capture this part by putting it in parentheses. This means I'm telling a regular expression to go find the pattern, but once it finds the pattern, only give me back what's inside the parentheses. And hence, it's only going to give me this part. Alright, so far so good. I managed to do it on this text, but the question is to do it on the data frame. So this is a very important and crucial step, solving the problem for one single value and then solving the problem for a sequence of values. First, I'm going just to put regular expression here. I like to import my packages in the beginning of my notebook. Second, I'm going to write a function. Actually, I'm going to write two functions. Let's call this one function 1 extract IP, and it will take a text as a parameter. It will compile this regular expression, and then it's going to return xp1 find all txt. And I'm going to write another function. Let's call it extract timestamp. It will take a text as a parameter. This one is going to compile this regular expression here, and then is going to return exp2 find all text. So I just isolated this piece of code in a function, and I have done this because I want to repeat this operation, actually extract timestamp here, over all of the values in my data frame. Now my data frame here, df00, has one column called 0. If I take a look at this column, it's a series. Now here is the magic here. We have a series of values. In order to make a function that work on one value operate on the series, we can use the function apply. And we can apply extract IP, and we will get the IP addresses here. And we got them in a new series that shares the same index, so we can put it back again to our data frame as IP or IP address. Next, I'm going to do the same for timestamp, except that this time I'm going to extract the timestamp by calling the function extract timestamp. df00 contains 3 columns now, IP, timestamp, and 0. I want just to delete this column. There are different ways to delete a column. One way is to fancy index and just say, well, I only care about you two guys here, IP and timestamp, and then assign it back to df00. The other one is to call the function drop and provide the value or the values that we want to drop. In this case, it's 0 on the columns axis. And that's also going to drop 0 from the column axis. Either way, we can assign it back to df00 and df00.head. That's the final result here. And that's basically what we have been asked for. We have been asked to produce something like this. Okay. Now, in part 2, we need to repeat the same operation for all files. And then we will have 10 data frames, and then we will need to combine these data frames in one master data frame. This may seem like a daunting question. Indeed, it's not this difficult. We basically want to isolate what we have done in a function, and this function will process a file, and then we can process all of the files. So what we have done here is basically these series of steps. First, read the file. So I'm going to write a function called processFile, and this function is going to take a file name as a parameter. Okay, so I'm going to repeat that steps here. I can call it df00. I mean, that's fine. We probably want to call it df, but let's keep it as is. The crucial point in here is to link this to the file name, right? Because we want to process a new file. And I'm simply going to isolate, copy all of the steps from above to this function. So those functions are already there. What I'm going to do, I need this one, this line of code, df, IP, timestamp, dropping, and basically that's it. Return df00. So what I have done here, I wrote a function that, given the file name, let's try it. I'm going just to copy the file name here. It's going to give us a data frame for that specific file. That's for 00. If I do it for 01, I should see a different result here. That's for 01 and so on. All right, so we're almost there. Next, we need to apply the function on all of the files. Well, we know that we have 10 files here. That's the question telling us 00 to 09. So what I'm going to do here, I'm going to write a list comprehension to generate these files name. These files name have this specific pattern, data server log 0, and this goes from 0 to 9, right? Let me double check. It goes from 0 to 9. So basically I'm going to vary this one, and I'm going to make it a parameter I. Obviously this is now a formatted string. And what I'm going to do here, I'm going to generate this for I in range 10, which basically means I will go from 0 to 9. And you can see here, we've got the names of the files here. So let's call these file names here. Next, instead of processing one file, I'm going to process all of the files. I'm going actually to process file name for file name and file names. And this is basically a list comprehension, and I am going to get a list of data frames. Let's call this one data frames. So this is like magic. Actually, data frames is a list of data frames. If I get a look at the first one, I get a data frame. The next one is a data frame, and so on and so forth. Because it's a list of data frames, the last step is to concat. So it's basically simply concatenation of data frames. Data frames. And I'm going to ignore the index here because I just want to re-index the whole thing. And that's basically going to give me the master data frame. I'm concatenating across the row axis by default. Let's take a look at the master data frame. And that's the master data frame here. It contains 1,000 rows, 2 columns, and that's what we're expecting because each file contains 100 rows. So that's what we are expecting from this exercise. Very often, once we are done combining the data we want to save, we were not asked to do this, but nonetheless, I'm going to show you the step. If I want to save this one, I can do master.to the file format I'd like to save to. Say I want to save to a CSV file, I can provide the name of the CSV file, data for instance, master.csv, and if I hit enter, it's going to save that data frame for me. So we can save this data frame and then use it for future analysis, analytics exercises.